In this next section and in this next chapter, we're going to be doing more solving of quadratic equations, meaning we'll be solving more things that have an x squared in them. And to do that, we'll be using a lot of square roots. You guys probably already know a couple things about square roots. For example, if I were to ask you about the square root of 25, or maybe the square root of 81, or 64, you guys would know the answer to these questions. You would know that this is 5, this is 9, and what multiplies by itself to get 60, that would be 8. So as you heard me talking about this example over here, you probably recognize that the square root asks what number multiplies by itself to get the number underneath the square root or the radical. And for numbers like these, it's not too bad because we know a number that multiplies by itself to give this. But what we're going to see in this chapter is sometimes we'll have to square root a number like this, or maybe a number like this. And off the top of my head, I can't think of something that multiplies by itself to give me 10 or 50. And there's a good reason why I can't think of one. Because it's a crazy decimal that'll make my whole calculator screen blow up with all kinds of numbers. And that's great if I want a decimal approximation. But a lot of times we're going to want exact answers, which means we're going to have to learn to take things like this and simplify them. So important things to know are that a square root says what multiplies by itself to give me that number. And we're going to use a special set of numbers called square numbers to help us figure out a way to simplify it. Square numbers are numbers that you get anytime you multiply something by itself. So for example, 4 is a square number. It's 2 times 2 is 4. That's a square number. 9, 3 times 3, another square number. This list I can go on forever. 4 times 4, 5 times 5, 6 times 6, and this literally can go on forever. I think you guys would be really smart to know all of your perfect squares up to, I don't know, 144, maybe 169. This happens to be 12 squared. This happens to be 13 squared. I'll also say that for what we're doing, there are 2 square numbers I did not mention, 0 and 1. This is a square number. It's 0 times 0, but I'm not going to use it for what we're doing moving forward. This also is a square number. It's 1 times 1, but we're not going to use it. The other thing that I just want to emphasize in this video is there's a property square roots have where if you have a square root of 2 things and they've been multiplied together, you are allowed to break it up as the square root of one thing times the square root of the other. You can also do this for division if you need to. If you have the square root of something divided by something else, you can break it up as the square root of one thing over the square root of the other. That's because square roots come from this idea of what number multiplies by itself to give you what you had. Multiplication and division are related operations, and because square rooting relies so heavily on multiplication, it's allowed to do that. It does not work for addition. You cannot say the square root of something plus something else is the same as the square root of one thing plus the square root of the other. This is absolutely not true. And if you ever do that, I'll be really sad. But as you guys go through the videos, you'll see how I use these square numbers and this property to get a simplified version of some very complicated answers. And I also hope it's clear how a square root and a square might undo each other. We'll see how it goes. Good luck.